Now you'll notice all these fractions look a bit strange because they have numerators which are higher than the denominators, which makes them improper fractions. Nothing to be afraid of, because all you need to do is basically divide the top number by the bottom and then think about your remainders. So I know there are 5/5 in one whole, and when I've got 7/5, it takes me over a whole, which means it's more than one. 10/5 would be 2, because there's 5 for every one, and that's 7. So it's going to be 1 and something. Now 5s into 7 go 1 whole, and there would be 2 left over. But it's not 2 wholes, it's still 2/5, because that's the denominator I'm working with, 1 and 2/5. 6s into 8, again, go 1 whole, but you've got 2/6 left over. That could be simplified to 1/3. 4/9, well, I can get 4 into 9 twice, because 2 4s are 8. So 4/4, 1, 2, 3, 4, would give me 1 whole, and another 4/4, 1, 2, 3, 4, would give me 2. Now I've got 9, so that is still left over as 2 and 1/4. Applying that to slightly bigger numbers, 31/5, well, 5s into 30 go 6 times, and there's a remainder of 1, but that's 1/5. 6s into 25, well, 6 4s are 24, so that's 4 wholes, but I've got 1/6 left over. 73 into 9, so I'm looking at ninths this time. Well, 9/8 are 72, and that's 1/9 left over. Just put in some tricky green questions here down at the bottom to show that, there's something a bit strange about these. Well, 81 goes into 9 just 9 times with no remainders. That's fine. That's another way of representing a whole number. It's not a mixed number because there's not a whole number and a fraction. So that's just an integer. 48ths, 8 5s are 40. That's 5 wholes. 15 thirds, 5 3s are 15. So that's just 5 wholes.